Hey Algebra 2, today we're going to do chapter 3.4, which is linear programming. So what is linear programming? Well, so first of all, let's talk about optimization. And so optimization is either going to mean you want to find the maximum or the minimum of some value. Like if you want to optimize your driving time, you might want to find the minimum driving time. But if you want to optimize your profits, then you would want to find the maximum profits. So linear programming is one type of optimization or one way to figure out the optimal value of something. So for us, linear programming is the process of optimizing a linear objective function subject to a system of linear inequalities called constraints. So your constraints are due to the physical world, like maybe time can't be negative, maybe you can have a negative number of products. And so you have these constraints that you have, and they're going to be inequalities, and you're going to graph the inequalities. Okay, so it says the graph of the constraints is called the feasible region. So you're going to graph these inequalities, get an overlapping area, because they're inequalities, so they have shading, and this is your feasible region. Okay, and then you have an objective function. Your objective function is based off of kind of what you're talking about, and it's going to have a maximum or minimum, or it could have both, or it could have neither. And the maximum or minimum must occur at a vertex of the feasible region. Okay. It's going to have both a maximum and a minimum if it's a bounded area. So we're talking about, so if there's my axes, and we've graphed maybe that constraint and that constraint and that constraint. What I have is I have this bounded area, okay? So this would be the bounded area. And so that's going to have a maximum and a minimum. But if you have an unbounded area, which might mean like we just maybe have these three, and then our shaded area is everything out here, well, it's going to keep going forever, and it's going to keep going forever up. So it technically might not have a maximum. So let's look at an example. So this example, I have written out the steps. So you really need to make sure that you have these steps written out. So we want to find the minimum and the maximum value for this c equals negative x plus 3y. So this is your objective function. And you don't do anything with it till the end, but you need to know that that's your objective function. Okay, that follows these following constraints. So step number 1 is you need to graph all your constraints. Could be a couple of them, however many, you just need to graph them all. So let's see here, we have x is greater than or equal to 2. It's going to be a solid line on x equals 2, and we're going to shade. It's kind of hard for me to shade on here. So by that shading will be to the right because we want greater than. So there's my shading that way. Then we're going to have x is less than or equal to 5. So that is this line, and less than or equal to is going to be coming this way. Now, just for the sake of being able to see it, what I actually have at the moment is I have these two horizontal lines, and I have the shading between them. You wouldn't technically erase, of course, then you could technically kind of get away without doing all of your shading. So these two horizontal or vertical lines with shading between them. Y is greater than or equal to 0, so that's this way. Oops, that should be on the x-axis, shaded up. So right now we're in this area here. And then our last one starts at 12. So it starts at 12 and goes down 2 over 1. The deal with these is you want to catch vertices. So there's going to be one vertex. You want to be really careful down. And there's going to be another vertex. And these are all solid lines. And if I do a test point to see where to shade, if I put in 0, 0, I'm going to get 0 is less than or equal to 12. which is true, so I'm going to shade below it. So what I'm going to have is I'm going to have this kind of trapezoid area. I'm going to erase the rest just so we can see it. This kind of trapezoid area here is my overlapping region. So this right here. You have to know your vertices. So what are my vertices? So that vertex is going to be 2, 8. That vertex is 2, 0. That vertex is 5, 0. And then we have another vertex over here, which I believe is at 5, 2. Okay. So step number 1, graph your constraints. So it's exactly like a system of linear inequalities that you did in 3-3. Step number 2, find the vertices. That's what we just did. Step number 3, plug the vertices into the objective function. So because you have 4 vertices, you're going to do this 4 times. So I'm going to plug 2, 8 into my objective function, and it's going to be c equals -2 plus 3 times 8, which is -2 plus 24, which is -22. Then I'm going to plug in 0, so it's c equals -2 plus 3 times 0, so that's -2. And then 5 times 2, or sorry, 5, 2, is going to be c equals -5 plus 3 times 2, which is going to be -5 plus 6, which is 1. And I'm going to go down to this underneath here, 5, 0. Doesn't matter the order you do these. -5 plus 3 times 0, I mean -5. Okay, so that's step 3. Step 4, results are the minimum, maximum C. So which one of these is the minimum value? There's my minimum. And which one is my maximum? Nope, not that one. Let's try again. How about 1? Alright. 1 is my maximum. So find the minimum. Then we're going to write the minimum is -22, and find the maximum, and the maximum is 1. You need to make sure you have these steps right now. There's 4 of them here. Graph the constraints, find the vertices, plug the vertices in, find the minimum and the maximum. Let's look at one more example. Alright, this time we're finding the minimum and maximum value of c equals x plus 5y, and this time it has 3 constraints. So if we start with x equals 0, so the line x equals 0 is the y-axis, and we want to shade that one to the right because we want all of the x's that are greater than 0. Then our next one, we're going to start at 2, and we're going to count up 2 and over 1. Okay, and we're going to draw in that line. And if I plug in 0, 0, I'm going to get 0 is less than or equal to 2, which is true, so we're going to shade below that line. And our last one, I'm going to rearrange and move the x to the other side, so we're going to do -x plus 5. We'll start at 5 and go down 1. Gotta be really careful you hit your, you know where your vertices are. So there I saw that they intersected. And if I plug in 0, 0 here, I'm going to get 5 is greater than or equal to 0, which is true. So we're going to shade over here. And where do we have all of them? Well, we have all of them. Here I'm going to erase where we don't have all of them. We have all of them kind of down here. And not in here. So I think we're looking at is, one second, let me see if I can, there we go. It's kind of a light blue, but it's blue. We're looking in this area there. So in that area, can we find our vertices? I really only have 2. So we have this vertex here. Oop. I messed up my pen. I gotta get it back. that vertex there of 0, 2. And we have this vertex here of 1, 4. So if we try those, 0, 2, let's see here, and we're going to get C equals 0 plus 5 times 2, which is going to be 10. If we try 1, 4, we're going to get C equals 1 plus 5 times 4, which is going to be 21. And so the deal is, though, looking here, do you really think 10 is the lowest value you can get, or is there going to be a lower value down here someplace? There's going to be a lower value, and so this is an unbound region. There's no bounds over here. So really, we're going to say there is no minimum, but we have a maximum of 21, and those are going to be our answers. All right, we'll do a couple more examples in class. Let me know if you have any questions, and have a good day.